scuole e i 40 spazi espositivi e laboratori aperti a tutti in Piazza Unità. Prima di accogliere gli ospiti del prossimo evento, a nome dei promotori e copromotori della manifestazione, vorrei ringraziare tutte le istituzioni scientifiche di Trieste, città della conoscenza, e le istituzioni che hanno collaborato con noi, il main partner del festival, i partner e i content partner della manifestazione per il contributo fondamentale. Grazie anche ai media partner e ai partner tecnici. Infine, un grazie speciale ai 200 volontari di questa edizione. Ricordatevi anche di controllare il programma aggiornato degli eventi su www.triestenext.it, al quale potete accedere anche da questo codice QR. Buon ascolto e buon festival!
Hi. Good morning, everyone. Welcome to the last session of Trieste Next International Academy. First, I would like to thank all of you for coming to this year's edition, and I hope it was a very valuable experience for all of you. We are especially pleased to start off this session with 5 of your peers, of your colleagues at the International Academy that were selected to share some of their research. And we hope that, as well as all the other sessions, this could be a way to stimulate critical thinking, exchange ideas, and to create the sense of community so important in the practice of scientific communication. I will briefly introduce each one of the speakers, and they will have 10 to 15 minutes to present. And at the end of the session, there will be a few minutes for a Q&A. So let's start with Alessandra Gabriele. Alessandra holds a degree in biology and is currently pursuing a PhD in physics and nanoscience at the University of Salento. Her research centers on the synthesis and characterization of carbon dots, biocompatible fluorescent nanomaterials with strong potential for bioimaging. By refining synthesis methods and examining their optical and structural properties, she explores the use as safe, efficient cell markers capable of targeting specific organelles with promising applications in diagnostics and biomedicine. Alessandra, feel free to start.
Thanks. Good morning, everyone. The study I will present today is about engineered carbon dots for selective mitochondrial bioimaging. These fluorescent nanoparticles present great potential in bioimaging applications. And due to their high biocompatibility and low toxicity, they represent an interesting alternative to conventional fluorescent probes, such as traditional fluorophores and quantum dot. These nanoparticles, typically smaller than 10 nanometers, present remarkable optical properties like bright fluorescent, strong photostability, and tunable emission wavelengths. And this study tried to follow a multidisciplinary approach that combined the systematic variation of synthesis condition with different characterization technique and biological tests. Carbon dots are represent with a central carbon core, which may be either amorphous or graphitic in nature, and are coated with different functional groups, like amino, carboxyl, or hydroxyl group. And these nanoparticles, the synthesis of these nanoparticles can follow different approaches, the top-down method and the bottom-up methods. And the bottom-up approach focuses on building carbon dots from small organic precursors throughout controlled carbonization processes. The most important features of carbon dots is their strong fluorescence, and the fluorescent properties of carbon dots are influenced by factors such as size, morphology, surface modifications, and the incorporation of heteroatoms. In this study, we tried to synthesize carbon dots using different precursors, but the sample showed weak fluorescence and poor photostability, with the exception of those synthesized using different concentration in citric acid and urea. So we focus our attention on these carbon dots, and in this slide we can see the synthesis protocol in which different concentration of citric acid and urea were put into distilled water, and the solution was subjected to a microwave system and turned black. Then the solution was subjected to an ultrasonic treatment to fully homogenize the product. And then, after different cycles of centrifugation and filtration, the final solution was filtered using 0.2 micron filters, and the synthesis parameters are summarized in the table. Finally, we obtained 4 samples, and in this slide we can see the optical analysis with Raman spectroscopy for all 4 samples. In both 4 samples, we can see the characteristic D and G peak in Raman spectra. The D peak is related to the presence of defect in the materials, while the G peak is related to the presence of well-ordered structures in the material. And we can see how in sample 4 the G peak becomes more pronounced, and it indicates the presence of a well-ordered structure and the incrementation of crystallinity in the materials. Also, we passed to morphological and structural analysis, and in these images we can see a comparative overview between the 4 samples. And the best sample was sample 3, in which we can see the presence of a well-defined boundaries of our nanoparticles. So we focus our attention on this sample 3 and try to conduct other analysis, like in this image we can see, in image A, a system analysis. We can see an HAADF image that shows the intensity variation corresponding to different density in the atomic structures, and this image confirms the presence of carbon dots in sample, and also the elemental map in B and C, B for carbon and C for nitrogen, is related to the real presence of nitrogen into the carbon matrix. So confirm the coexistence of carbon and nitrogen in our samples. Also, an HRTEM analysis in this image we can see the lattice fringe, typical of a well-ordered structures in the materials, and the Fourier transform of the image highlights the reflection planes typical of the well graphite structures. The sample present a well-defined structure with an improvement in crystalline order, and we can see In this image, we can see a comparison between real images and simulated image from a single carbon layer. And we can see how the difference is particularly zero between the real image and the simulation of the image, showing the morphology of the selective carbon dot. We follow it with optical characterization. In this slide, we can see the absorption spectra. We can see the central band with the two peaks. The first peak is related to carbon-oxygen bonds, and the second peak is related to carbon-nitrogen bonds. And these peaks are important because the presence of carbon-nitrogen bonds is related to the chemical properties of carbon dot, and the presence of carbon-nitrogen bonds contribute to enhance fluorescence in our nanoparticles. Also, in fluorescence spectra, we can see an emission peak at about 530 nanometers, and the position and the intensity of this peak is related to the chemical and optical properties of our nanoparticles. Crucial for the application of our nanoparticles are to test our fluorescent nanoparticles to see the cellular permeability of our carbon dot. And we considered 3 cell lines, the 3T3 cell, 3T3 transformed with KRAS oncogene, and the NHDF neo cells. And to study the cellular permeability of CDOTs, we put different concentration of carbon dot with cell in the same cell medium, and in the confocal image, we can see the 3 cell lines and the different concentration of the 3 cell line and the different concentration of carbon dot, and we can see how the permeability of CDOTs has an incrementation in a dose-dependent manner. So, to evaluate the cytocompatibility of CDOTs, we have conducted an MTT assay that measure the cytocompatibility, so the metabolic activity of CDOT, and the test was performed using the highest concentration of carbon dot. In panel A, we can see the difference between the control and cells treated with carbon dot, and we can see how the difference is particularly in existence. So carbon dots do not compromise the metabolic activity in cells. In addition, another study for measure the fluorescent intensity in the 3 cell lines. In this image, we can see how the fluorescent intensity has an improvement in cells with the highest concentration of carbon dots. So, to study the intracellular localization of carbon dot, we focus our attention, and the preliminary experiments were made in mitochondria. In this image, we can see the NHDF neo in The first image, we can see mitochondria with the carbon dots. In the second image, mitochondria with a conventional probe used for mitochondria, for marker mitochondria, a mitotracker. And in the third image, C, we can see the merge between carbon dots and mitochondria, and we can see how there is a co-localization between our probe and the conventional probe. And in the fourth image, we can see a detailed co-localization analysis between carbon dots and the mitotracker that demonstrates a substantial overlap with an 18% of the signal of carbon dot and the mitotracker in the mitochondria. So this result suggests the application of carbon dot for specific analysis of mitochondrial structures and function. We can see other images related to the other cell lines, the TT3 and the KRAS, and the use of the confocal microscope to observe the cellular uptake of carbon dots provides a clear visualization of the intracellular localization of carbon dot and confirm the ability of our fluorescent nanoparticle to permeate in different types of cells. So the future perspectives will be to test our carbon dot with long-term toxicity study to evaluate the cytocompatibility of our fluorescent nanoparticle in long-term studies, and put together the functional information from confocal microscopy with the ultrastructural information derived from electron microscopy to conduct a correlative analysis and use our fluorescent nanoparticle like a double marker to track physiological and pathological events in biological environment. An additional applications for our nanoparticle is print using ink with carbon dots. And a special thanks to my group from Unisalento, and thanks to my professor Antonio Serra and team to University of Bari. And thanks for your attention.
Thank you, Alessandra. Now let's move on to Fuat Berke Gül. Fuat holds a degree in mechanical engineering from Istanbul University and a master's in energy science and technology from Istanbul Technical University, where he's currently pursuing his PhD in the same field. After gaining industry experience, he worked as a research assistant at the Turkish-German University from 2020 to 2024, and now serves as a lecturer at Bandırma Oneydi Eylül University. His work focuses on renewable energy and life cycle assessment, with particular emphasis on hydrogen technologies, wind energy, carbon footprint, electric vehicles, and building energy proficiency. He has contributed to numerous EU, national, and institutional projects and provides training, consultancy, and mentoring in energy management systems, carbon footprint analysis, and energy technologies. Fuat, whenever you're ready.
Thank you for introducing me. Thank you everyone to attend this session. Today I want to try explain something about artificial intelligence control of automotive compatible proton exchange or polymer electrode membrane fuel cells. Sorry, the other one. Yeah. Actually, this is my PhD study. So what I do or what I did during this stage, during this time, actually I design a dual stage direct current and direct current converter suitable for hydrogen fuel cells, and derived this system model of the dual stage DC-DC converter and performed its simulation, and getting simulation results. After getting simulation results, I use different controllers to monitor outputs from these converters. Then create an algorithm for artificial intelligence-based control methods, then compared simulation results between them. So my study involves artificial intelligence algorithm to perform control. This is so necessary for PEM fuel cells and also for the vehicle that includes it. And I get information from operation conditions like temperature, humidity, pressure, gas concentrations, current voltage, etc. And the artificial intelligence algorithm learned this data and learned this information to operate a fuel cell at minimum fuel consumption and also at maximum efficiency. Then the algorithm actually control the converter and also minimize the ripples and optimization problems that I will explain. 5 minutes ago, I forgot everything that I say. So sorry for this. I'm a little bit excited. Sorry. And the algorithm learns the operation conditions and it receives from the fuel cell to perform a maximum power point tracker. And I will explain what's this, and enable minimum hydrogen consumption. Oh, sorry. Actually, what is fuel cell and how can we use hydrogen as a fuel? Generally we use hydrogen as a fuel in rocket or in space vehicle technologies, but the hydrogen use in this field the role of the bursting or burning. But this system, we have an electrochemical method to get electrical energy. We have electrolyte, but not in aqueous solution. This is a solid electrolyte, and it works with diffusion of electrons from cathode to anode, or anode to cathode, actually. And with this way, we can take electricity and we can use this electricity in direct fuel cell or hybrid electric vehicles. But definitely we have a problem, or we have limitations when we use hydrogen in electrical vehicles. So why I'm doing this study, or why am I study these topics? Absolutely, I have some reasons for this study. Actually, first of all, I want to increase the prediction capacity of hydrogen consumption. Yes, we use hydrogen, we consume hydrogen, but we want to limit this. And we want the system works with a higher efficiency level, maximum efficiency. And also, I want to digitalize energy technologies, especially hydrogen technologies, with artificial intelligence and data learning. What is the benefits of these processes, or maybe this works? Lower hydrogen consumption. This is the first and also the important thing. Compared to equivalent electric vehicles with the same range, and also a more efficient and effective control structure, control procedure, and this system will learn driver's behavior. I will explain also this in the next slide. And early response is so important when the speed changes, and we need quick adaptation to system when intentions or sudden current requirements. Yeah. I saw two significant problems with hydrogen fuel cells using in electrical vehicles. Especially, we don't get, or we don't have enough energy or enough power for electric vehicles. For example, we have a cell, hydrogen cell, and with cell by cell, we have stack or stack, yes, a hydrogen stack. For example, 24, 38, maybe 400 stack. Yes, we have limitations about current because of the components of the cell, hydrogen cell. We have limitations, but for voltage, this is about the amount of the cell. But when we arise the amount of the cell, for example, 400 or 500 cell together, it rises weight and weight of the vehicle. So we need more power to motion or to transport the vehicle. This is the main problem. We need voltage, we deliver more cell, but after weight problem, we didn't use more cell to, we can use more cell to motion our vehicle. So maybe I can say the other problem is control of the fuel cell and the fuel cell power output. So the fuel cell struggles adapt to cars rapidly changing current demands. For example, when we use a car, sometimes we need to brake or we need to give a gas. So suddenly we need go rapidly or slow down, and the current always changing with this movements. So this system rapidly adapt this structure or these changes and control all vehicles and also battery and also fuel cell to prevent fatigue or lifetime losses. So we can solve these problems with the algorithm that I created, and I will explain also this one. But I can say something about the current studies. The current studies actually use industrial and also standard controls in the system. But we need specialized control systems for fuel cells on, or also for fuel cell vehicles. And I was trying to developed a control system suitable for hydrogen fuel cells. And the solutions that I thinking about it, a controller incorporation and artificial intelligence based algorithm, and also I want to prevent the problem, this control problem, with learned algorithm learns the fuel cell output voltage and also creates or occurs a duty cycle to arise or boost the voltage, and the voltage will be stabilized and required level. Actually, I can explain these direct current converters like this. We have a voltage output, yes, but this is not enough for the car or vehicle, and we need to rise this current that requires level. So we don't need to add more cells or more modules to our fuel cell. We can use directly this converter to higher voltage. And the second solution that the algorithm acts as a controller, and it control voltage output, and also the signal comes from a converter. And the second target is the algorithm maximizes the efficiency by finding maximum power point tracker. We have a diagram of voltage and power, and the optimized point of this power and voltage curve is the maximum power point. And we have a controller that it always finds a maximum power point to get maximum efficiency and to get maximum power. And the algorithm also use this method to get maximum power. And algorithm learns, as I mentioned, current and voltage for vehicles usage process. For example, when you buy the car and you started to use it, first 20 kilometers, the algorithm will learn your driving skills, your speed, and also your consumption, and it develops a optimized method or optimized system to minimize hydrogen consumption and maximize the hydrogen fuel cell efficiency. So we have two benefits actually. This system with the algorithm, thanks to algorithm, the system responds quickly the current changes, and also always works with maximum efficiency and maximum performance. Yeah. And with this study, I created a digital twin of this hydrogen fuel cell, and I created a converter, and after that, I made an algorithm, artificial intelligence algorithm, to apply my system, especially in hydrogen fuel cell. So this is the fuel cell system model. Sorry, some part of seems like Turkish, and maybe you can see Turkish, some words, some Turkish words, maybe. and our different syllable. So this is my output. First one is current output, the second one is voltage, and the third one is power and the temperature of stack. The temperature of stack directly acts current. So I use this information in my algorithm. And I simulate this model under the fixed duty cycle. Normally, this is not possible, but I wanted to see its performance under a fixed duty cycle. So as you see, the voltage, the yellow one is the output voltage, and the blue one is voltage after direct current converter. The voltage is rises, multiply 4 times, and after that, the PI MOSFET controller. Generally in literature, the researchers and also the companies use PI controller, and with the PI controller, you can see this part. There are a lot of ripples and oscillations when the signal transports to actual fuel cell. Then the PI MOSFET controller again with a long range, and I applied fuzzy logic controller, and this is my roles and parameters for fuzzy logic. This is the fuzzy logic controller results. The left one is the short range, and the right one is in a long range. As you see, the oscillation and the ripples, I mean this higher and lower, or upper and down, the signal of magnitude of the signal. The ripple is lows and downs, and the oscillation is reduces. And this is the supervised learning control. Actually, this is a machine learning method. So with the machine learning method, we can take the best performance with the machine learning method. This is supervised learning. And I can actually say, as I mentioned, I designed the MATLAB Simulink model, then simulate this model after getting information like voltage, current, temperature. I fed this information to algorithm. Algorithm controls the direct current converter, and after controlling, it show me results that supervised learning, actually a machine learning method, gives us a best solution to maximum performance, maximum efficiency, and also best control of signal and response. Yeah. In the future works that I need to work hard to get this one, and also I need to learn English again, maybe from starting after this session. I will apply ANM methods and RNN methods, recurrent neural networks, genetic algorithms, to see results and discuss about the results. Yeah, this is my future works. Thank you for your patience, and thank you for your attendance. Thank you so much.
Okay, thank you, Fuat. Now our third speaker will be Ante Mrše. Ante is a pharmacist and PhD candidate at the University of Zagreb, specializing in the phytochemical characterization and biological activity of Polygonum species, as well as the optimization of terpene extraction from Helichrysum italicum. Currently working as a research assistant, Ante has expertise in phytochemistry, pharmacognosy, and chromatographic techniques. His previous experience includes roles as a senior production technologist at Carca Pharma and as a pharmacist at Pharmacy Talan, where he integrated research insights with pharmaceutical production and patient care. Ante, whenever ready, please begin.
Thank you very much for the nice introduction, and thank you for coming here. I know it's Sunday, it's sunny. It would be nice to sit outside and drink a coffee, but I thank you for coming out and listening to me and my colleagues to hear what our research is about. So, a lot of long words. This research, which is it's not so complicated, was made in collaboration from me, from the University of Zagreb, my mentor, and my colleagues from the University of Mostar and Charles University in the Czech Republic. So, what's it about? It's about green extractions and the activity and variety of extracts of volatile compounds, mainly terpenes, of the plant species Helichrysum italicum. I hope some of you heard of that. Probably not under this name, but under the name immortelle, or in English also called curry plant. It's an evergreen aromatic shrub, which is native to the Mediterranean. It's very aromatic. It's often used as a base for perfumes. So if you're not heard of it, you've smelled it 100%. But besides the nice smell, it's often used as a traditional medicinal plant, mainly for the skin active effects, wound healing, and other skin conditions as hematomas and sunburn. As said, the essential oil is the main, the primary therapeutic fraction, and that's why it has attracted a lot of scientific attention in the last 10 to 15 years. But before we can start any kind of scientific research of medicinal plants, we have to isolate the bioactive compounds. So how do we do it? Through different process of extractions. Here are mentioned some of the main ones: solvent extraction, distillation. Distillation is especially important if you want to extract volatile compounds as essential oils. And I mentioned here a novel method, which is supercritical fluid extraction in natural products, mainly CO2 extraction, about which I'm going to tell you a bit more now. So hydrodistillation, if you don't know, is a pretty simple process. You boil water, and then the water vapor goes through the plant material and extracts essential oils. It's simple, it's straightforward. You don't use toxic solvents, you only use water. So it's pretty good. The negative side is you have to bring water to high temperature. So if you have any thermolabile components, they will degrade. Another bad side is that it lasts for 3-4 hours, sometimes longer. So if you don't have much time, or if you want to be effective and efficient, it's not really your go-to method. But it was, for a long time, the only method we had for volatile compounds. But in the last few years, more and more research is being done on the supercritical CO2 extraction, or supercritical fluid extraction, which is extraction where you bring the extracting medium, in this case CO2, to a supercritical state. So you put high pressure on it and relatively high temperature, and then the CO2 goes into a state between gas and liquid. So it has still the extraction potential of liquids, but the movement of a gas. So it moves much easier through the whole plant matrix and accesses the glands in which the essential oils and volatile compounds are much more easy. Another pro of the method is that you have a high purity of an extract. the temperature is raised, yes, okay, but not to 100 degrees, but to 40 to 60 degrees. So there is much less risk of thermal degradation. Another interesting effect, which is something I'll do more in the future, is that you can tune the selectivity of the extraction with different parameters of pressure and temperature and the flow of the solvent of the extraction media. You can get different fractions of the volatile compounds, but more on that later. But not everything is great with the supercritical CO2 extraction. The machine is pretty expensive and it's not so easy to handle. I mean, if you buy the machine, if you spend thousands and millions on it, you're going to learn it, but it requires time. Okay, so now after this brief introduction, a little bit more about the actual research. What was my aim of the research? Helichrysum is interesting, so we wanted to compare different extraction approaches on helichrysum. The standard hydrodistillation, which is the standard and commonly used, in comparison with supercritical extraction with different parameters. On the different extraction parameters later. After we have our extracts, we were going to compare them through different aspects and in the end give a biological and pharmaceutical standpoint through evaluating its antioxidant activity of hydrodistillate extract and CO2 extract. And now to the results. Before starting any of it, as a pharmacognost, it's a pharmacist who works with medical plants, we always look first under the microscope. Why? Because especially with essential oils, you need to see where the essential oil is located. If it's deep inside the plant, if it's on the surface, and you choose your extraction methods based on that. So we looked, this is one flower of helichrysum, which looks nice. And then we looked for the essential oil glands so that we know where the essential oil is stored. We saw that there are multiple multicellular bisserate glandular trichomes on the corolla, this part. But we noticed that on the ovary is filled with numerous curved short bisserate hairs, which both contain essential oils. So with this step, we confirmed our suspicion that the essential oil is located on the epidermis, so on the surface, and that hydrodistillation and both CO2 extraction is a viable extraction method for this plant. After that, we did our extraction. This on the right, on the right is, from your perspective on the left, is the apparatus for hydrodistillation. If you look at the yields, it's plain that it's plain to see that the hydrodistillation had the lowest yield of extraction, only 0.34%. But that is expected because through these conventional methods, Immortel has not a high yield of essential oils or volatile compounds. But what surprised us, or me, was that CO2 extraction had a much higher extraction yield, especially when we use this second set of parameters. Now, you may ask, why did you choose these exact parameters? They are not random. They are taken out of a research paper my colleague from Mostar published. She tried to optimize the extraction parameters for a plant species called Artemisia annua, which is in the same plant family. So we chose those parameters to additionally test if the same principle of Artemisia annua are applicable to Helichrysum italicum. I mean, they're in the same plant species, so they have some similarities, but they're not so similar. So it's not just copying that. Okay. So as said, this is the apparatus for hydrodistillation, and this beauty is the CO2 extractor. I'm not going to go into the details of how it works because we would sit here a long time. So after we got our extracts, different extracts, 3 different extracts, we were going to identify which compounds are in which extracts because, okay, it's the same plant, the same sample, which we took our drug, herbal drug from, but different extraction methods can, of course, differ the fraction of all compounds which are extracted, but some extraction methods can give you different our suspicion was that hydrodistillation will give us one set of compounds and CO2 extraction part of that too, but new compounds as well. I'm not going to go into the details of the method, but I'll tell you how we identify the compounds. We identified it by a method widely used in pharmacognosy, and that is gas chromatography paired with mass spectrometry. And it gives us an insight of the fraction and the identity of compounds in our extracts. And after we put our samples in the machine, we get something like this, a whole bunch of peaks. On these tables, every peak represents a single compound. And depending on where the peak is and which mass spectrum is behind it, we can identify which components are in our extracts. I'm not going to bore you with the chemistry and physics behind it, but I'll talk a bit about these sections that I circled. So you see that on the essential oil gas chromatograph, you see a lot of peaks at the beginning. That is a group of volatile compounds called monoterpenes, and they are pretty famous in immortality, in helichrysum. You know? They were expected to be found on the gas chromatograph. I was honestly a bit disappointed that we didn't have more of them in the CO2 extracts, but the good thing is that we found on the CO2 extracts these peaks, which are big. The bigger, the more of those compounds you have. And those are part of a molecule group called sesquiterpenes, which have shown in the literature very high activity in biological assays as antioxidant activity and skin-related activity, which is in pair with the traditional use of immortel. As I said, it's often used in skin diseases and treatment of skin conditions. This is a numerical representation of some of the peaks. Most of them are identified, but because of the limitation of the machine, only about 85% of them are identified. But I took out the ones with the largest share. In the table, I again highlighted Neril acetate talidion 1 and 2 because they are the most important compounds found in helichrysum or immortel for the cosmetic industry until now. But if we are going to use it in the pharmaceutical industry as health remedies, maybe these later peaks will be more important in the future. As said, at the end, after identifying compounds in our extracts, we are going to make a relatively simple test of antioxidant activity of our samples. I presented them here through IC50. The explanation of IC50 is here is that the concentration of the extracts which is necessary to get 50% of antioxidant activity in the methods used. And what was very interesting for me is that the CO2 extracts showed a much higher antioxidant activity than the hydrodistillate extract, which I honestly did not expect because not a lot of people are working with supercritical fluids with helichrysum. And I thought that somebody tried it and got no results and then abandoned the study. But these results are very promising for further research because we used these two extraction parameters from our other research paper. And we showed that there is a huge difference in antioxidant activity and in the composition of the extract. So that makes place for further research and optimizing, making it experiment design for optimization of extraction parameters of supercritical extraction of helichrysum. So I don't know how I stand with the time. I hope I'm inside the 15 minutes. 2 minutes, great. That will be enough. As a conclusion, to sum everything up. So we wanted to compare the extraction of helichrysum through CO2 extraction and hydrodistillation. Before that, we showed that those two extraction methods are viable through microscopy. The yield of the supercritical extracts were much higher than the yield of the hydrodistillation, especially when the supercritical extract were used at higher pressure. The CO2 extracts showed lower share of monoterpenes, that those were the peaks on the start, but much higher peaks at the back, which represent a higher share of sesquiterpenes. And the CO2 extracts showed a much better ability to inhibit DPP-H radical scavenging, or in other words, a much better antioxidant activity. So what are the next steps? As said, optimization of extraction parameters of helichrysum, and that considering different things. So the first thing is we want to optimize, of course, the yield that we get, because I mean, it's economy. The more you get out of the sample, the better it pays. But not only the yield, but the contents too, and of course, the antioxidant activity, because it's the real value of the sample. You can have different compounds inside, but if they don't work synergistic and give a stronger activity, they're not so valuable standing alone. Besides that, we are going to these new extracts. We are going to analyze them with a bit more advanced method. Up until now, we use GCMS. Now we add another mass spectrometer in the series, which will help us, I hope, to identify 100% of the compounds in the extract. And because helichrysum is used as in traditional medicine as a medicinal plant in skin treatment, we are going to test our extracts to skin-related enzymes. I hope I didn't bore you too much. Thank you for your attention. And yeah.
Okay, thank you, Ante. Now we're moving on to Thu Nguyen. Thu is a PhD student in biochemistry and molecular medicine at the University of Oulu, Finland, and a member of the EU Greener RPP Consortium. Her research lies in the intersection of biotechnology and sustainability, focusing on the development of protein cell factories that produce high-quality recombinant proteins with homogeneous and authentic N-termini. Aiming to improve the sustainability of biopharmaceutical production, her work explores in vivo strategies as greener alternatives to traditional in vitro methods.
So thanks for being here. Today, I'm going to introduce a novel in vivo strategy to produce proteins with homogeneous and authentic N-termini nuclei. So my project is about protein production, and it's more about applied science rather than fundamental research. So I hope it's not too boring for you. So let's start with the title. Homogeneity and authenticity of recombinant proteins are very important and have a great influence on the quality of the final pharmaceutical product. However, obtaining these properties remain challenging at some point particularly due to the complexity associated with the N-terminal methionine processing. So what is the problem? So for recombinant protein cloning and expression, the process is simply to put the ATG start codon in front of the open reading frame. And after the transcription and translation, the newly synthesized peptide will have methionine at the first position. And the N-terminal methionine can be removed by an enzyme called methionine aminopeptidase, or the MAP enzyme, to create the authentic sequence. However, this MAP enzyme only can cleave before some amino acid, and the cleavage efficiency sometimes cannot reach 100%. So the protein after expression can be either native or with methionine at the first position. The N-terminal methionine is vulnerable to oxidation, which might affect the protein stability, and the non-homogeneous product typically exhibit different immunological and pharmacological properties. So these two forms are unacceptable in many cases. Strategy have been done before to overcome the problem, like overexpress of the MAP enzyme, or engineer the MAP enzyme, or combine fusion and cleavage strategy. All have their pros and cons, but none of them have introduced a system that can be used to produce every protein with authentic N-termini. So that's our project objective, to develop in vivo cleavage systems in E. coli that generate a protein with homogeneous and authentic N-termini. And we expect to have a system that can be used for all protein of interest, regardless of the N-terminal amino acid. Highly specific, because we need to use it in vivo, which means that we will express the protease in the E. coli cell. Everything happens inside the cell, so it needs to be highly specific so that it will not affect the E. coli host cell or affect the protein of interest. And we want to have a system that is strain and media independent so that it can work well in both academic use and industrial scale production under different conditions. And finally, cytosol independent. Cytosol is a system that can be used for the cytoplasmic disulfide bond formation in E. coli. So if anyone expresses the protein in E. coli, you might know that we can't produce the protein with disulfide bond in the cytoplasm of E. coli. So that is a system that can be used for that purpose. The workflow includes 3 main steps: database analysis to find a good candidate, creating, screening, validating the system, and optimizing the system. And we start with 10 proteases at the beginning, and after several steps, we pick one candidate for the final, like the initial in vivo cleavage system. That's called proline aminopeptidase. So what is the proline aminopeptidase and what is the strategy? Proline aminopeptidase is an exopeptidase that catalyzes the removal of proline at the N-terminal of a peptide. In our strategy, we put the proline after the first methionine to make sure that the MAP can remove the first methionine. And after that, our proline aminopeptidase, the PIP enzyme, will remove the proline. And then we have the POI with authentic N-termini. So that's the strategy. And the system, to test the system, we pick a protein of interest or a model protein called IPC-PA. It's like anti-VEGF dapin. And to evaluate if the enzyme is active in the E. coli cytoplasm, we co-express of the IPC-PA and the PIP enzyme in the E. coli cytoplasm. And as you can see in the SDS page out here, both PIP and IPC-PA were highly spread in E. coli cytoplasm and highly soluble. And when we decide the protein substrate, IPC-PA, we put the C-terminal histag so that we can purify using IMAT, and then analyze the cleavage efficiency using the LCMS, the spectrometry, to see if it still have the proline at the N-terminal or without the proline at the N-terminal. And that's how we evaluate the cleavage efficiency. And as you can see, The PIP is active in the E. coli cytoplasm, and the cleavage efficiency can reach 100%, both with and without cytosol. So now the system worked. We want to test if it can work with all protein of interest, and we can't test all the protein of interest. So we change to amino acid after the cleavage site of IPC to other 19 amino acid, and we check the cleavage efficiency. We change by site-directed mutagenesis. And as we can see here, the PIP can remove the proline before all amino acid, however, with different cleavage efficiency. And low cleavage efficiency was observed before some charged amino acid, like glutamic acid or lysine or arginine. So the system worked, but it needs further optimization. There are several factors that might affect the cleavage efficiency of a protease, like we see the first and the second amino acid. It can also be reaction time or the flexibility of the substrate so that it can enter the active site of the protease. Now we focus on two different factors, the reaction time and the N-terminal flexibility, to see how it affects the cleavage efficiency of PIP. And yeah, we see that when we increase the reaction time from 24 to 48 hours, in all cases, the cleavage efficiency was improved. And similarly, when we insert a flexible linker to the N-terminal, in many cases, the cleavage efficiency was improved, but not all cases, which means that not only the flexibility or the first and the second amino acid after the cleavage site, but also other factors affect the cleavage efficiency of the enzyme. So we know that the longer reaction time worked, but we don't really want to increase the reaction time because in industrial scale, longer reaction time means costly, time consuming, and so that we should focus on the longer flexible N-terminal region, and we can target the pre-folding stage of the protein where the protein is still flexible before the folding. And for other observation, we see that the cleavage efficiency was quite low before some charged amino acid. So we need to do some protein engineering to improve the cleavage efficiency. To target the pre-folding state of protein, we tried two different strategies. Pre-expression, where we spread the PIP like 16 hours before the induction of the POI, so that when we spread the POI, the PIP is already there, so it can cleave the unfolding stage. And the second strategy is to do the ribosome association, where we put the PIP, the enzyme, into the ribosome, where it can target the pre-folding state of the protein, the newly synthesized polypeptide at the exit tunnel. So that is a strategy, and yeah, the two strategy work well. The pre-expression can improve the cleavage efficiency from 50 to more than 80%, and the ribosome association, so the cleavage efficiency of 100%. So the ribosome association is the one that we use for further experiment. And we tested the system in different strain and media to see if it like highly compatible, and as you can see, the cleavage efficiency reached 100% in all the tested conditions with the substrate IPC. So in short, we have a system. It works in different conditions, and it can cleave before all amino acids, but the cleavage efficiency needs to be optimized. And we are doing some other experiments, firstly to improve the cleavage efficiency and the substrate specificity by protein engineering. Some mutation worked, but not very well. We need to combine different mutations to significantly enhance the cleavage efficiency. And we also apply the system to produce other pharmaceutical proteins, like the growth factors or the cytokines. And last week, we performed a proteomics analysis of the PIP expressing strain, because when we express the protease in the E. coli cell or express something else that's active in the cells, it might affect the function of the cell. So we need to do the proteomics to make sure that it does not affect the normal function of the cells. And finally, we want to scale up for further application. So this is my group in Oulu in Finland, and this is the consortium that I'm working with. And yeah, thank you so much for your attention.
Thank you. Thank you too. Last but not least, we will hear Angelo Valente. Angelo is a research fellow at the Department of Developmental and Socialization Psychology at the University of Padua. His work focuses on psychological resilience and well-being in technologically advanced work environments. Angelo also collaborates on projects exploring problematic digital media use among young adults and the role of digital technologies in supporting mental health, particularly in individuals with chronic illnesses. Angelo's research interests include digital mental health and the psychological impacts of human-technology interaction.
Thank you for your presentation. Let me say that I'm quite emotional to be here today, especially because this is the first international event that I participate for. So I'm so glad to present you my contribution about the psychological resilience in the Industry 5.0 paradigm by putting a particular focus on the relationship between problem-oriented coping strategies, social support and organizational resources within the manufacturing sector. So let's start with a brief theoretical background by saying that, as we know from the current literature, production systems contribute in a prominent way in producing economic welfare. In fact, with the Industry 4.0 paradigm, we witnessed on one of the most important societal changes consisting into the integration of advanced automated systems and collaborative robotics in order to empower the workers' duties and also the production outcome of these facilities. So, despite the several challenges that manufacturing industries are expected to coping with, Industry 5.0 paradigm propose an innovative vision for this sector by putting the human being at the core of industrial transformation. So the Industry 5.0 are building an innovative theoretical framework which stems on three main pillars representing human centricity, sustainability, and resilience. So in this sense, the next generation of operator within manufacturing sector are expected to withdraw and proactively react to the future external disruption which affect these facilities. And for this reason, authors are conceptualizing the Operator 5.0 regarding essentially new professional figure that overcomes which goes beyond the mere technical competencies in order to empower the synergistic collaboration between human and machines. So as we can deduce from this picture, psychological resilience could play a key role in cope with crisis, manage stress, or simply maintain high level of productivity within these small production systems, these smart production systems. And so from psychological research, we can affirm that they could strongly contribute to enhance the context of human-robot interaction. Generally, we know this construct as the capacity to cope with, adapt to, and recover from adversity and stress by putting a particular emphasis on the internal resources that we implement to bounce back from external difficult experiences. So, From this picture, we decided to design our study in order to fill a crucial gap in the current literature regarding the availability of validated psychometric questionnaires regarding the psychological resilience within the sector. So essentially, we aim to develop and preliminary evaluate CareQE 5.0, psychometric tools measuring psychological resilience for manufacturing workers operating with high-tech machines in the manufacturing sector in order to administrate that and also validate it for our future studies. To be more specific, in this day, I will deep the understanding of the relationship between the individual problem-solving strategies, social support, and organizational resources in relation with the technology-related factors. So, our study was structured in several phases by beginning from a broad literature review in order to identify a validated psychometric questionnaire with high level of internal consistency. This phase was crucial to identify potentially strong item which composed our first prototypical version of the questionnaire. Then the other phases was useful to enhance the clarity and the semanticization of item that have been adapted to the manufacturing context. To be more precise, we administered our first set of item firstly to a small pool of experienced occupational psychologists and following this phase through a 2 focus group session with manufacturing workers. These phases were crucial to obtain our first prototypical version of CareQE 5.0 that was also administered to a broad sample of manufacturing workers during a pilot testing. With respect to statistical analysis, we compute the content validity ratio for the expert evaluation and the aggregated analysis and thematic analysis for the focus group session in order to enhance the semanticization of our item that was, as I said before, readapted for the manufacturing context or for the manufacturing settings. But today I will focus on the pilot study results. So I have to underline that for this study, for our research, we assess the preliminary psychometric properties of CareQE using descriptive statistics, internal reliability analysis, and Pearson's correlation between individual problem-solving strategies, social support, and organizational resources without forgetting the prominent role of technology-related variables. So, our questionnaire was essentially structured by 2 main dimensions, assessing the individual resilience and the perceived organizational resilience, represented by the sub-factor that I mentioned before. To be more specific, individual resilience was measured with the problem-oriented coping strategies, and the organizational dimension was represented by the social support comprehensive of colleagues, family, and organization, and the organizational resources represented by the skill-based and the individual-based resilience, without forgetting, as I said before, of the technology-related variables. Our study was implemented after the approval of our interdepartmental ethical committee and consisted into a questionnaire administration via Qualtrics platform for an average time of 20-25 minutes for each workers. CareQui 5.0 was presented as a self-report questionnaire, which was completed through a 5-point Likert scale for a data collection period of 2 weeks. So, as yielded by the cake graphics, our total sample of recruited workers from the recruited manufacturing structures from the northeastern part of Italy include 44 workers with an average age of 35 years old. Then, as yielded by the graphics, our sample was predominantly composed by Italian male workers employed in operational duties. Then, as reported by the red cake graphics, the majority of our sample declared to have intermediate levels of technology readiness. Then, concerning the other technology-related variables, the frequent technology use reported high scores out of 5-point scales, frequency scales. And concerning the years of experience with technology, our sample declared to have almost 16 years of experience within their home facilities. Then, this table represents our descriptive analysis. As you can see from the table, we just reported the mean scores and the standard deviation scores. So, from this table, we can see that we can infer that our sample frequently use problem-oriented coping strategies to solve problem during their working everyday life. Other interesting suggestions are displayed by the social support dimension. As we can see from the main point, the main points, our sample perceived colleagues and family more supportive than their own organization, which yielded us lower points and higher variability. Then, concerning the organizational resilience, as we can see from our mean scores, our sample reported greater average point concerning their perception about their companies' capabilities in strengthening their technical skills, but as well as the main shared perception about the individual resilience implemented by their colleagues. Obviously, as we can see by the standard deviation scores, these perceptions are not equal shared by our sample. Then, lastly, as yielded by our internal reliability scores, our item clearly measured the construct of our questionnaire ranging from 0.79 to 0.94 Cronbach's alpha points. Then, this graphic represent our correlational analysis, and as we can see, all the psychological and organizational, individual and organizational variable that we assessed present in general significant and positive correlation. Just to give you an example, the problem-oriented coping strategies yields significant are positively associated to greater perception by their family, colleagues, and companies, as well as yield positive correlation concerning the dimension of skill-based individual in the individual-based resilience. Then concerning the technology-related variables, our sample yielded us negative and not so significant correlation. So what can you infer from this result? First of all, that active coping strategies foster psychological resiliency in high-tech manufacturing context. Then other important hypotheses about these results can be done, for example, regarding the social support dimension, because our workers using active problem-oriented coping strategies, for example, are seen and seen themselves as more capable of managing stress and change within these manufacturing facilities. Lastly, we can also infer that the technology-related variables play a limited role, maybe a peripheral role in fostering a psychological resilience. So we can also affirm that psychological resilience relies more on cognitive and interpersonal resources than from technology-related resources of manufacturing facilities. I have to underline that our study is still preliminary, so despite the promising results that I displayed before, our sample is still too strict to generalize our results to other regional or sectoral fields. So factor analytic validations are required. For example, by beginning from an exploratory factorial analysis in order to explore the latent structure of CareQE 5.0, followed by a confirmatory factorial analysis, and lastly, followed by a multi-group CFA in order to assess the equivalence across demographic groups of the manufacturing workers. So my presentation is over, and I thank you so much for your attention.
Thank you, Angelo. Thank you very much to all the speakers. Unfortunately, due to time constraints, we won't have time for the Q&A. We have to go straight to lunch, but I encourage you to interact with the speakers during lunch. Today, we will eat at Da Pino. It's in the same direction as Rosa Pomodoro. We just have to walk a few more meters, okay? Thank you.